Good afternoon, everybody. We have to be study the next part of this amplifier section, that is the H parameter section. But before seeing the next part, we have to be revise whatever part we have to be covered in the last lecture, right? So in the last lecture, we have to be seen that determination of different amplifier parameters such as AV, AI, RI, RO. What it indicate that? You indicate that voltage gain, AI indicate that current gain, RI indicate that input impedance. See. And RO indicate that output impedance, right? See, these four terms we have to be seen in this session. Now, see, to see that particular parameter, we have to be discuss the thing with respect to the amplifier. Why? Because see, we have seen the characteristic or the thing related to the H parameter, thing related to the transistor, right? The application of transistor we have seen here, it is as an amplifier, right? In this case, why we have to be see this thing with respect to the different parameters. See, when we have seen the transistor indicate that whatever their application, that should be means analysis of that amplifier application we should need it. That's why we have seen the different parameter of the amplifier, right? See, above figure shows that the transistorized amplifier circuit, means block diagram of transistorized amplifier circuit, right? In that diagram, we have seen that Vs is nothing but input applied to this configuration. After all, that input impedance is called as Rs, and the Rs, that is input impedance through this configuration. I1 is the current flowing through the input circuit, and Q1 is the voltage applied across your input circuit. So see, did you getting my voice? Please reply.
Yes, sir.
Yes.
Okay. Due to the application of Q1 voltage and I1 current, there should be generation of output voltage V2, and at that time the current is I2, right? So here Q1 as the input voltage, V2 as the output voltage, I1 as the input current, I2 as the output current, and here we have seen the fourth thing, that is Ri indicate that input impedance, RO indicate that output impedance, and voltage gain as well as current gain, right? In this configuration, we know that the current which should be entering towards the rail, that should be positive. So here IL and I2 that are same, but IL is entering towards the RL. That's why the value of IL is positive. So IL equal to minus of I2, because that current going towards the outward, right? So IL equal to minus I2. That should be seen here. Means further on, when we are discussing with respect to load current, in that case, the current should be IL, and the value of IL that should be minus of I2, because current entering towards the node, that should be considered as a positive. The current going outside, that should be considered as a negative. That's why IL equal to minus I2. See, we have seen the first point, that is a determination of current gain, right? Determination of current gain. See, what do you mean by current gain, what do you mean by voltage gain, that we have to be seen. See, any of the thing we have driving purposes need of the current, not a voltage. See, voltage indicate that it should be not a power. So current indicate that it should be act as like as power. So current gain of the any of the device, that should be important for us, right? So that's why we have to be seen the current gain. See, gain, any of the gain is nothing but it is the ratio of the output to the input. So in this case, current gain is nothing but it is the ratio of output current to the input current, right? Output current to the input current. So in this configuration, we have seen that output current is nothing but a I2, but that should be going towards the amplifier. That's why it is a negative. But the thing should be coming with respect to output, that is IL. So IL current is the output current. So see here, IL is the output current which should be coming with respect to your devices. The input current, see, input current indicate that whatever the current flows through the input. So your current gain is nothing but it is the ratio of output to the input. So IL divided by 1, it is the current. Actually, it is nothing but a minus I2, but initially output is IL and input is I1. That's why IL upon I1 is nothing but your current gain. Okay, but IL value is nothing but a minus of I2, because it should be going outside of this node. See, so AI equal to, AI indicate that current gain which is equal to IL divided by I1, right? So see, we know that IL value, we have seen that IL equal to minus of I2. See, IL equal to minus of I2. So we have to be put, see, we have to be put this value on above equation. So it is nothing but a minus of I2 divided by I1. Okay, so we know that, see, this is the equation with respect to current. So we have two H parameter equation, which are that one is with respect to V1, with other is with respect to I2. So here this should be related to the current. That's why we have to be seen the second equation, I2 equal to H21 I1 plus H22 V2, right? See, H21 indicate that it is the ratio of the I2 to the I1, means I2 to the I1. It indicates that I have to indicate that output current to the input current. So it is called as forward current, right? So HF, that's why it is called as HF. I1 as it is plus H22. H22 indicate that it is the ratio of I2 divided by V2, right? So it is nothing but an output admittance, right? So that's why we have to be written as a HO and V2 as it is. So your equation is I2 is equal to HF into I1 plus HO into V2. Okay, this is the equation we have got. Now in this equation we have no HF into I1 plus HO into V2. This is the equation. But during this equation, we know the value of the V2. See, we know that the value of V2. See, I am seeing the how V2 we have to be seen. V2. See, we know that Ohm's law V equal to IR. Okay, so related to the current and resistance, that must be we have seen. V2 equal to IR. So IR indicates that related current is IL and RL. So V2 equal to IL into RL. V2 equal to IL into RL. But we know that the value of the IL, it is a minus I2, right? So V2 equal to minus I2 into RL. So see, whatever the value which should be coming in this, that should be substituted on this equation, right? So HF into I1 plus HO into minus of I2 into RL. But see, minus of I2 into RL doesn't write. We have to be written here as a minus. See here. See. I2, which is equal to HF into I1 plus HO into bracket of V2 value minus I2 into RL, right? So see, this minus I2 going here, it is nothing but HF of I1 minus of HO I2 RL, okay? HO I2 RL, because this minus going as here, okay? Now in this equation, I2 is here, right? I2 is here. This is minus of HO I2 into RL going on another side. See, it changes the sign. So plus of HO into I2 of RL. Okay, this HF into I1 as it is. HF into I1 as it is. See, I2 we have taking as a common in between both. So I2 into bracket of 1 plus HO into RL. Okay, so HF into I1 as it is. Okay, I2, this I1 going on another side, it is a divided. So I2 divided by 1. This 1 plus HORL going on another side, so it is nothing but a HF divided by 1 plus HORL. Okay, so the equation we know that output divided by input indicate that current gain. So current gain equal to AI equal to plus HF divided by 1 plus HORL. This is the equation. याच्याबद्दल कोणाला काही प्रॉब्लेम आहे का? रिवाइजला पार्ट होतं, थोडं फास्ट घेतलं. कोणाला काही समजलं नाही किंवा काही प्रॉब्लेम आहे का सांगा. जस्ट टेल मी. रिस्पॉन्स द्या. लक्षात आलंय का?
येस सर.
ओके, नसेल आले तर लक्षात घ्यायचं, नाही म्हणून सांगायचं. कधी फोर्सफुली कधीही कुठलं करायचं नाही. ओके, we have seen that is the revised part. We have seen actual topic, right? See, in this case we have to find out the second thing, that is the determination of voltage gain. See, how we need of the voltage gain, current gain, RI and RO, that I'm telling you. See, when we have to be design any of the amplifier, see, capacity of that amplifier we have to be seen. Capacity indicate that in which area that should be used, right? So according to that, it must have requirement the current gain, right? So that's why current gain finding purposes we need of the AI. Okay, voltage gain indicate that sufficient power that should be amplified, that is nothing but a voltage gain. RI indicate that input impedance of that particular amplifier. RO indicate that output impedance of the particular amplifier, right? These are the things used for the purpose of designing the particular amplifier and for the particular area. Okay, see, determination of voltage gain. Voltage gain indicate that it is the ratio of the output voltage to the input voltage. We know that any of the gain is nothing but it is the ratio of the voltage to the output to the input. So voltage gain indicates that it is the ratio of output voltage to the input voltage. See, F equal to P2 divided by P1. This is equation number 1, right? See, but we know that we have already seen that Phi2 equal to IL into RL. We have put out the same thing here. See, Phi2 equal to IL into RL. Okay. So in that equation, we have to be written as a Phi2 equal to IL into RL. Okay. But we know that another thing, another thing, that is current gain also. See, current gain, we have seen that current gain is nothing but output divided by input. So IL divided by I1. Okay. So IL equal to AI into I1. IL इकडे ठेवला आणि I1 इकडे नेलं. So IL equal to AI into I1. So why that we have to be done? Because we have to be find out the V2 value. So V2 is nothing but a IL into RL. But we know that IL value, right? We know that IL value. IL is equal to AI into I1, right? So that's why we have to be done this equation. But see, IL equal to AI into I1. This should be put it on this equation. So V2 equal to, for IL we have written as a AI into I1 into RL. हे लक्षात आलंय का सांगा मला. का रिपीट करू एकदा? प्लीज रिप्लाय द्या. परत एकदा सांगतो.
नो सर,
नो नीड.
समजले, रिपीट करायला.
Okay. So we know that Phi2 equal to AI into I1 into RL. This is equation form with respect to Phi2. Okay. So Phi2 equation means whatever the value coming from Phi2, that should be put it on above equation. 1 minute. See, we have seen that the thing with respect to this equation, Phi2 equal to AI into I1 into RL. This is the equation, right? This Phi2 value, which we have to be put it on this equation, right? See, Phi2, for that purposes, we have written AI into I1 into RL. So AI into I1 into RL, Phi1 as it is, okay? So your equation is AV equal to AI into I1 into RL divided by Phi1. This is the equation coming, right? This equation, during that equation, what we have to do? Other equation is coming AV equal to AI as it is. This RL value, we have taken here RL value, and this I1 going on another side. Another side indicate that below. So your equation is coming AI into RL. This I1 going below. So Phi1 upon I1. Right, Phi1 upon I1. So your equation is AI into RL divided by Phi1 upon I1. Okay. So we know that Phi1 upon I1. We know that R equal to Phi upon I. Right? R equal to Phi upon I. But this Phi1 and I1 indicate that input. Right? So that's why for the purpose of Phi1 and I1, we have to be written as a R, right? R equal to V upon I. But this R is with respect to input. That's why AI into RL, this for that we have to be written as a RI. Okay. So AV equal to AI into RL divided by RI. Okay. This is the equation we have got. हे लक्षात आलंय का? मी हे परत सांगतो तुम्हाला इथून लक्षात घ्या. Whatever the value which we have got with respect to V2 is equal to AI into I1 into RL. Okay, this is the value of the V2. So whatever the value of V2 we have got, that should be put it on this equation 1, right? So see, AV equal to this AI into I1 into RL divided by Phi1 as it is. Okay, Phi1. But see, AV equal to next thing, AV equal to AI. Now RL is as it is, RL taking as it is. This I1 going downward below, right? Going below. So it is nothing but a AI into RL divided by Phi1 upon I1, right? Phi1 upon I1. right? So see, we know that phi1 upon I1 is nothing but a R, right? It is nothing but a phi upon I is nothing but R, but 1, that's why it is nothing but a Ri, this thing related to the input, right? Your equation is AI into RL divided by Ri. So your equation is V equal to AI into RL divided by Ri. लक्षात आलं का?
Yes, sir.
Okay. This is the equation with respect to the voltage gain. Okay. Now we have to find out the other parameter, that is input resistance. Input resistance with respect to your amplifier. So we know that input resistance, we know that Ohm's law, R equal to V upon I. So your input resistance is nothing but it is the ratio of the input voltage to the input current flowing through the circuit. Okay. So Ri equal to V1 upon I1. For that purposes, we have required the equation first, P1. P1 is equation for H converter is equal to P1 is equal to H11 I1 plus H12 P2. Okay, so we know that H11 indicate that it is the ratio of the P1 upon I1. So V1 upon I1 indicate that it is the input impedance. So for that purposes, we have to be written as a HI I1 as it is. Okay, H1 to indicate that it is the ratio of the output current. Sorry, input current to the output current, or it is the ratio. Sorry, H1 to indicate that it is the ratio of the input voltage to the output voltage. Right, input voltage to the output voltage. So it is nothing but a Phi1 upon Phi2. So Phi1 upon Phi2 indicate that reverse voltage, right? Output to the input, it is a forward, input to the output, it is a reverse, right? So for that purposes, we have written as a HR. HR indicates that reverse voltage, Phi2 as it is. Okay, so we know that another thing, particular value of the Phi2. Phi2, we know that Phi2 is nothing but IL by IL into RL. आपण हे बऱ्याच वेळा पाहिले, V2 equal to IL into RL, but IL is nothing but a minus I2 into RL. Okay, V2 equal to minus into RL. This should be value put it on the equation earlier. Okay, so earlier equation we have to be put the same value. So your equation is nothing but a Phi1, see this equation, Phi1 HI into I1 plus HR into this minus I2 into RL. So that's why middle minus. See, HI into I1 as it is, this HR as it is, Phi2 indicate that minus I2 into RL, minus I2 into RL. That's why we minus taking here. So your equation is Phi1 is equal to HI into I1 minus HR into I2 into RL. Now this, whatever the value coming across in this equation, that should be substituted on the equation number 1. Means for the V1 we have to be written this value. So for Phi1 we have written as a HI into I1 minus of HR into I2 RL. See here, Ri equal to HI into I1 minus of HR into I2 RL. This is the equation. I1 as it is. Okay. So Ri equal to, see this I1 divided by this, only this factor here is not I1. So that's why HI I1 divided by I1, it is nothing but only HR remaining. HI, okay, minus of HR, and this thing I2 divided by I1 taking separate out, RL as a multiplied thing, right? So your equation is Ri equal to HI minus HR into RL I2 divided by I1. सगळा पोर्शन परत एकदा सांगतो. See, in case of calculation of determination of input resistance, we have to be find out the things such as input impedance. We know that R equal to P upon I, right? For that purposes, we have written with respect to input resistance, input voltage is P1, input current is I1. So Ri equal to P1 divided by I1. This is the equation number 1. So to find out the P1 and the input impedance, we have required the term that is a H1 term, H11 term, right? So that's why equation is nothing but a Phi1 which is equal to H11 I1 plus H12 Phi2. Okay, so we know that H11 indicate that it is the ratio of the input voltage to the input current. So it is called as input impedance. So HI into I1 plus H12 indicate that, see, H12 indicate that it is the ratio of the input voltage to the output voltage. So it is called as the reverse voltage because output to the input forward. So it is called as HR into V2. Okay, so we know that another thing, but we know that V2 equal to IL into RL. V2 equal to IL into RL. Okay, so IL indicate that minus of I2. We have seen that already, minus I2. So that's V2 equal to minus I2 into RL. Okay, so for that thing, we have to be written as a V1 equation as it is. V1 is equal to HI into I1 plus, now see, I'm telling you, plus, see, plus HR into V2. V2 indicate that minus of I2 to RL. That's why here we have to be written as a minus, right? That's why here minus. Okay, already here is a plus. Okay, so the equation is coming V1, which is equal to HI into I1 minus of HR into I2 into RL. This equation should be coming. Whatever the value we have to be coming, this value, this V1 value, we have to be put it on this equation. So Ri equal to V1 indicate that HI into I1 minus of HR into I2 RL divided by I1 as it is. Okay, so see, for all of the equation which is coming across here, we have to be divided by I1 separately. See here, so HI1 divided by I1, so I1 cancel. So your here only HI is remaining, HI. Now see another, this side minus sign, HI minus HR into I2 RL, HR into I2 RL. So for that equation, we have written HR into RL, this I2 divided by this I1. Why this I1? Because this I1 is going only for this I1, only for this sign is here minus. That's why here is the remaining I1. Okay, so the equation is minus HR into RL I2 divided by I1. Okay, so your equation is RI equal to HI minus of HR into RL I2 divided by I1, which is equation number 2. लक्षात आलंय का? प्लीज रिप्लाय द्या. नसेल आले तर आपण आणखीन एकदा रिपीट करू. आला असेल तर सांगा पुढे जाऊ. इथपर्यंत लक्षात आलंय का?
Yes, sir.
ओके. See, we know that we have seen the things related to the Ri equal to HI minus HR into RL I2 divided by 1. But we know that one of the equation with respect to the current gain, that is AI equal to minus I2 divided by I1, right? So AI is indicate that minus I2 divided by 1. So for that minus I2 divided by I1, we have to be put out as a AI here, right? So see, during this equation, HI minus of HR into RL. So minus of I2 divided by 1 we have put out as a AI. So minus is going here. So HI plus here what is remaining? HI plus this is AI into HR RL. Okay, see here. Ri equal to HI plus AI HR RL. Okay, this will be coming. Okay, so see, we know that another equation for the current gain. Current gain we have seen already. Current gain equation minus HF divided by 1 plus HO RL. Okay, we have to be put out the same value here, right? So see, AI equal to minus HF divided by 1 plus HO RL. So same value we have to be put on this equation. Okay, so see, Ri equal to HI, this minus as it is minus, for that it is a HF divided by 1 plus HRL into multiply by HRRL. See here, HRRL. So your equation is Ri equal to HI as it is, this minus HF HRRL divided by 1 plus HORL. Okay, 1 plus HORL. This equation should be coming. Okay, so this is the equation for the purpose of input impedance, right? हे लक्षात आलंय का सांगावं लागेल एकदा. सांगतो, बट इथपर्यंत लक्षात घ्या. Ri equal to HI minus HR into RL I2 divided by 1. We know that I2 divided by 1 is nothing but a current gain, that is a negative of minus, see, negative of the I2 divided by 1 minus of I2 divided by 1 is nothing but a AI. So for that purposes we have to be written as a, it is a AI. So Ri equal to HI plus AI into HR RL, right? So see, AI, we know that the value of the AI, as we have seen here, HF divided by 1 plus HORL. For that purposes, we have written as a minus HF divided by 1 plus HORL. Okay, so see, this is the value. So Ri equal to HI as it is, this minus is coming here. So HF as it is, HRRL divided by 1 plus HORL. So your equation for Ri is equal to HI minus of HRRL divided by 1 plus HORL. This is the equation, right? But in this equation, see, in this equation, what we have to do? Ri as it is, HI as it is. Now see, HFHR, after all that HO, if we have to be taken as a HO as a common thing, means जर आपण याच्यातलं काय केलं, RL न जर HO ला मल्टिप्लाय केलं, पहा RL न जर HO ला मल्टिप्लाय केलं +1 केलं तर तीच व्हॅल्यू येते, पहा RL HO +1, त्यामुळे आपण याचं कॉम्प्लेक्सिटी कमी करण्यासाठी काय केलंय, 1 + RL + HO केलंय. हे पहा RL × HO याची सुद्धा व्हॅल्यू हीच आहे, RL × HO +1, ओके, RL × HO +1, ओके, कॉम्प्लेक्सिटी कमी करण्यासाठी आपण हे केलं. ओके, सो इक्वेशन इज Ri equal to HI minus of HFHR HO plus 1 upon RL. ओके, लक्षात आलंय का हे लास्टचं इक्वेशन?
Yes, sir.
ओके. See, whatever the thing we have to be calculated, that is HAP, HRE, HOE, etc. That thing also calculated with respect to the particular parameter that indicate that these are nothing but a H parameter, right? So this H parameter we have to be calculated by using graphical also, right? Graphical measurement of the particular thing indicate that HI. Okay, so see, for the calculation of the particular HI with respect to the graphical, it is the plot of base emitter voltage versus base current. Okay, so for finding the graphical measurement of the particular parameter, that is the HI, we have to be need of the graph of the base emitter voltage versus your base current. So for that purposes, we have to be draw the plot of VB versus IB. In that plot, we have to be find out the different value, means we have to be plot out the VB versus IB plot by taking VC is constant, right? VC indicate that collector to emitter voltage. So in this case, we are taking the 3 value collector to emitter, that is collector to emitter 1 value, collector to emitter first value, and collector to emitter second value. This value finded for the purpose of finding the HI value, right? HI value, we have need of the HI indicate that it is the input impedance. Input impedance indicate that it is the ratio of the Q1 to the I1. Q1 indicate that input voltage, I1 indicate that input current, right? So for the calculation of HI, we have need of the Q1 to the I1. So by this parameter purposes, we need of the Q1 ratio upon I1, and so that's why we have put out this graph. This graph is nothing but a VB versus IB and different value of the VC, VC1, VC2, and VCQ value. So that VC value, these are the different value, means what we have to do for the plotting VC1, VCQ, VC2. First we have seen how the VC value we have to be plotted, right? For that purposes, we have taking the VC value, VC1 value as a constant, and we have to be increases the value of the VB, right? Only we have to be increases the VB value and plot the value of the IB. Okay, so in that case, your plot is VC1 plot. To find out the VCQ, Q indicate that quotient point. It is also called as minimum operating point of the particular transistor. So for that purposes, we have to be taking the VB value, this VC value, VC quotient value taking as a constant value and changing the value of the base to emitter voltage, right? So we have to be increasing the value of the VB and plotted the value of the base current. So we have got this plot for the VCQ. Then after all, another parameter, that is VC2. So in this case, we have taking the VC2 indicate that collector to emitter voltage. It should be taken as a constant, and we have to be increases the base to emitter voltage, right? Base to emitter voltage we have to be increasing, and the note down the value of the base current. So we have got this type of the graph. So in this case we have to be taking the three value of the VC, that is VCA1 and VCAQ and VCA2, and find out the particular value of the base current. So for that purposes we have to be increasing the value of the VB only, right? And the for finding the HI indicate that input impedance, we have need of the relationship with respect to particular y and x axis, right? Y and x axis indicate that it is the ratio of the C. Your x axis indicate that it is the voltage, your y axis indicate that your current, right? So your ratio for calculation of the HI is nothing but it is the ratio of the phi to the I. Phi to the I indicate that it is the thing with respect to y as well as x, right? So finding the this thing indicate that y2 divided by y2 minus y1 divided by x2 minus x1. So y2 indicate that this is the thing, right? This is the thing. Y2 indicate that this is the y1, this is the y2, right? This is the y2. So y2 minus y1 divided by this x value, so IB2 divided by I1. So your parameter which should be calculated for HI, it is nothing but a y to the x. So y to the x indicate that y2 minus y1 divided by x2 minus x1. So y2 indicate that this value, phi value. So phi b2 minus phi b1, right? Phi b2 minus phi b1 divided by x value. X value indicate that this current, IB2 minus IB1. So IB2 minus IB1. So it is nothing but which respect to we have to be changing. So we have to be changing the PB value and IB value. So actually HI is the ratio of the changing VB value to the changing base current value. So it is nothing but a delta VB divided by delta IB. Delta VB divided by delta B. Delta indicate that change in, right? So HI value, for the calculation of HI value, we have to be find out the change in base to emitter voltage to the change in base current, right? This is nothing but a VB divided by IB. When we have to be taking other parameters. See, I'm already told you this parameter we have taken as a constant VC, VC1, VC2, and the VC2. This thing we have to be taking constant. We have to be changing the VB value. See, VB value, and at the same time, due to the increasing changing the VB value, there should be changes in the base current. So it is nothing but a change in indicate that delta VB divided by delta IB at the constant of the collector to emitter voltage. This is the calculation for the HI. Okay, याच्याबद्दल कोणाला काय प्रॉब्लेम आहे? कोणची थिंग लक्षात आली नाही ते सांगतो तुम्हाला, तेच सांगा. म्हणजे HI ची व्हॅल्यू जर आपल्याला मॅथमॅटिकली काढायची असेल तर इट हॅव इट्स फॉर्म्युला, बट वी ऑल्सो टेक दिस व्हॅल्यू बाय युजिंग दिस ग्राफ ऑल्सो, राईट? Any problem? Please tell me. लक्षात आलंय का कसं काढायची HI ची व्हॅल्यू? प्लीज रिप्लाय द्या. रिपीट करो?
No, sir.
Okay. See, another parameter, HRE. HRE indicate that it is the R indicate the reverse, that is voltage ratio, right? HRE indicate that it is the ratio of the input voltage to the output voltage. So input voltage to the output voltage, it is the reverse thing, right? So V1 upon V2, it is a reverse thing. So for the calculation of this thing, we have to be seen the reverse ratio of the voltage, that is V1 to the V2, right? So to finding the HRE value, we have to be taking the plot of, see, we know that HRE indicate that it is the ratio of the V1 to V2, right? So for that purposes, we have required the two things, that is a voltages, two voltages, that is a input voltage and the output voltage. In this case, your input voltage is base to the emitter voltage and output voltage is the collector to emitter voltages. So in this case, we need of the VB versus VC. Okay, because in this thing with respect to HRE we have need of the input to the output ratio. So this is the input voltage, this is the output voltage, that is we have to be seen. So actually for the graphical measurement of HRE we have to be plot the graph of the VB versus IB. VB indicate that base to emitter voltage, IB indicate that base current. So in this case what we have to be calculated. See, we have to be taking out the value of the VB, we have increasing the value of the VB and note down the value of the IB Q. In that case, we have taking this VC1, VCQ and VC2 as a constant, right? As a constant for particular thing. लक्षात ठेवा. म्हणजे इथं मी तुम्हाला आता सांगितलंय ऍक्च्युअली काय करावं लागतंय, चेंज इन व्हॅल्यू काढायचे कोणत्या VB वर्सेस VC, आणि मी आताच तुम्हाला काय सांगतोय की हे कॉन्स्टंट ठेवायचंय. बघा दोन्ही मध्ये चेंज झालाय, पण ऍक्च्युअली तसंच आहे. ते कसं सांगतो मी, काय सांगितलं तुम्हाला, डेल्टा VB डिवाइडेड बाय डेल्टा VC काय इंडिकेट करताय, चेंजिंग व्हॅल्यू. इथे मी तुम्हाला काय सांगितलं, VC कॉन्स्टंट ठेवायचंय, VC2 कॉन्स्टंट ठेवायचंय, पण या व्हॅल्यू चेंज आहेत ना, VC1 ची व्हॅल्यू चेंज आहे, VC2 ची चेंज आहे, लक्षात घ्या. त्यामुळे हिअर for the plotting of the HRE we have seen that we have changing the value of delta VB and the delta VC. So it indicates that we have taking the VC1 value and VC2 value. See, right? This is the change, right? We doesn't see it should not be changed. It should be changed, but particular value it should not be changed. Means when we have to be taking, see, I'm telling you, when we have to be taking the plot of VB versus IB for the particular value of the VC, means in this case, whatever the value of VC considered as a 5 volt, it should not be changed, but it should not be changed. Means we have taking the plot of the VB versus IB for the value of VC1 value we have to be considered as a 5 volt. So we have to be increases the value of the VB and taking the value of the base current. This should be coming with respect to the VC even. So we got the plot of the VB versus IB at the value of VC, but when we have to be taking the plot of the second consider as a VC2, in that parameter we have taken another value of the VC, it considered as a 7 volt, VC2 value it should be 7 volt, and we have taking the increasing the value of the VB and the taking the value of IB. Okay, so increasing the VB, taking the value of the IB, so we got the plot of the VC2. But for that purposes we have required the value of the both changing delta VB, delta VC. For that purposes we have used the two things, that is VB indicate that these two change, right? VC indicate that also to these two change. म्हणजे इथे जे चेंजिंग VC ची केली ना आपण, त्यासाठी हे दोन वेगवेगळे VC घेतोय. हे जरी कॉन्स्टंट असले तर या VC या पर्टिक्युलर ग्राफ साठी कॉन्स्टंट आहे आणि हा VC2 या पर्टिक्युलर ग्राफ साठी कॉन्स्टंट आहे. म्हणजे हे दोन वेगवेगळे आहेत, लक्षात घ्या. ओके, so see, determination of HRE from input characteristic. Input characteristic indicate that the things with respect to your input voltage with respect to the input current. Input voltage applied across your transistor, that is a base to emitter voltage, and the current, that is a IB, that is base current. So when we have to be drawn the plot of VB versus IB for the different value of the VC, there are three value of the VC, that is VC1, VC2 and the VCQ. Q indicate that constant point, it is nothing but a minimum point. Minimum indicate that we have applying the minimum voltage to the transistor to work in a amplifier condition. So this is the graph of the question point, right? So to calculate the particular HRE, what we have to do, draw a horizontal line through the operating point Q. See, these are the operating point. So which are the point? See, which are the point which should be coming with respect to VC1 and VC2. We have write down that point as a horizontal line, horizontal line on that factor, right? Horizontal on that factor. So this line indicate that IBQ, right? IBQ value. This should be taking as a constant value. IBQ should be taking as the constant. So for that purposes, we have required the input voltage to the output voltage. So we know that input indicate that VB. So taking the value of this two VB2 minus VB1 divided by output voltage. Output voltage indicate that VC2 minus VC1. So it is nothing but a VC2 minus VC1 taking as a base current constant. So in this case, what we have to do, we have to be taking the value of the base current at different level, it is nothing but a change in. So when we have to be calculate the HRE, in that case we have taking this different value of VB, it indicates the change in VB. It is also called as delta VB. We also done the other voltage parameter, that is output voltage. This is also changing, that is VC1 and VC2. So this is nothing but a delta VC. So for the calculation of HRE, what we have to do, we have to be taking the value of the input voltage to the output voltage. We know that see, whatever the value coming with respect to input and output, that should be in the form of change in, right? So it is nothing but a delta VB divided by delta VC. So HR equal to delta VB by delta VC. We are taking this base current as a constant, right? So it is nothing but a, for the calculation of the HRE, we have tell as a VB2 minus, see, it is nothing but actually why, what, when we have to be calculate the HR value, it is nothing but a Y2 minus Y1 divided by X2 minus X1. So it is nothing but a VB2 minus VB1 divided by VC2 minus VC1. We have taking IB as a constant. This is the equation for the purpose of calculation of the HRE. याच्याबद्दल कोणाला काय प्रॉब्लेम आहे का सांगा ना.
तर IB कॉन्स्टंट का बरं घ्यायचा?
बेस करंट कॉन्स्टंट का घ्यायचा याचा रिझन सांगतो की ज्यावेळेस आपण HRE काढतोय HRE इंडिकेट दॅट इट इज द रेशिओ ऑफ द इनपुट व्होल्टेज टू द आउटपुट व्होल्टेज. लक्षात ठेवा, जर तिथं मी बेस करंट जर कॉन्स्टंट ठेवला नाही, बेस करंट जर व्हेरी व्हायला लागला, तर आपल्या V1 आणि V2 चा रेशिओ सारखा चेंज होत राहील. लक्षात घ्या, सारखा चेंज होत राहील. त्यामुळे आपल्याला इथला जो बेस करंट आहे ना, तो कॉन्स्टंट ठेवा, त्यासाठी ठेवावं लागेल. लक्षात घ्या. आणि ऍक्च्युअली कसं असतं, जर आपल्याला एखाद्या पर्टिक्युलर गोष्टीचा रेशिओ घ्यायचा असेल तर अदर पॅरामीटर कॉन्स्टंट ठेवावं लागते. इथं सुद्धा पहा आता मी काय करतोय, VB व्हर्सेस IB चा प्लॉट घेतोय, बरोबर. VB व्हर्सेस IB चा प्लॉट घेतोय, पण ते करत असताना मी काय करायला लागलोय, अदर पॅरामीटर कॉन्स्टंट ठेवायला लागलोय. अदर कोणती, VC1. म्हणजे तो प्लॉट जर काढायचा असेल तर कुठली तरी एक पॅरामीटर कॉन्स्टंट ठेवावं लागते. लक्षात घ्या. त्यामुळे ज्यावेळेस आपण VB आणि VC याच्या मधला प्लॉट काढतोय ना, VB आणि VC मधला काढतोय, त्यावेळेस ह्या दोन्ही काढतोय, बरोबर. हे दोन्ही व्हॅरी करतोय, म्हणजे कुठली तरी एक कॉन्स्टंट ठेवावी लागेल. त्यासाठी आपण बेस करंट कॉन्स्टंट ठेवतोय. लक्षात आलं का?
येस सर.
ओके. दोन स्लाइड राहिलेत खरं तर, मला म्हणजे ओळखायचं नाहीये हे, पण एक स्लाइड तरी घेऊ आपण याच्यातली. ओके. सी, डिटर्मिनेशन ऑफ HAP इंडिकेट दॅट. लक्षात ठेवा, HAP हा कन्सेप्ट तुम्हाला करंट गेन साठी सगळ्यात महत्वाचा असतो. म्हणजे जर एखाद्या ठिकाणी तुम्ही गेला, अँप्लिफायरची गेन खूप जास्त आहे असं म्हणतात, गेनचं व्हॅल्यू देत नाही, तिथं HAP देतात. लक्षात घ्या, HAP इंडिकेट दॅट करंट गेन. So HAP indicate that it is the ratio of the output current to the input current. So for finding the determination of HAP indicate that output current to the input current. For that purposes we have need of the two current, that is a output current and the input current. Okay, so to find out the input current and output current, here also we have taking the one of the term as a constant. ते का करावं लागेल, जर ती व्हेरी करत गेलो तर तुमचा रेशिओ ऑफ आउटपुट टू द इनपुट काढताच येणार नाही. लक्षात घ्या. सी, determination of HAP indicate that it is nothing but a HAP indicate that it is the ratio of the output current to the input current. So output current to the input current indicate that whatever the power, it indicate that whatever the power of your amplifier, right? So see, to finding the HAP, we have taking out the plot of the VC versus IC. We have taking out the plot of the VC versus IC. We have changing, see, we are changing the value of the VC, note down the value of the IC, right? So for that purposes, this is the plot of the VC versus IC. And another thing, see, another thing we have taking as a different value of the IB, right? So we are taking the three value of IB. So for that purposes, means determination of HAP, what we have to do, we have taking out the plot of the VC versus IB and the taking the base current, particular base current as a constant. So for that IB1, what we have to do, consider IB1 value, it should be taking as a 5 milliampere, right? So 5 milliampere is the current taking as a constant, and we have to be, see, we have to be vary the value of the VC and plot the value of the IC on this parameter, right? This parameter. So we got the plot in this way. In this way, we have to be got the plot of it. Again, we have to be changing this value of the IB1. So IB1 value should be changing with respect to Q. Q indicate that question point. Question point indicate that we have applying the voltage to the transistor to work as an amplifier, right? Sufficient voltage is applied to amplifier. It should be worked as an amplifier. So in that case, we have changing again the value of the VC and taking the value of the IC. So in that case, we got the plot of this of IBQ value means we have taking the IBQ value as a constant and changing the value of the VC versus IC, taking this plot. Same way, we have taken another value of IB2 consider as a 20 milliampere and taking by increasing the value of the VC and taking the value of the IC. So this in this time this graph is formed. Okay, so this is nothing but a IB1, IBQ, and IB2. This is called a change in base current. So it is nothing but a delta IB, right? Delta IB. So to determination of HEP from output characteristic, we know that HEP indicate that it is the ratio of the output current to the input current, right? For any of the transistor, we know that output is coming across your collector terminal and input is coming across your base terminal, right? So your whatever thing coming with respect to this is nothing but it is the ratio of the output current, that is a output current indicate that collector current, right? So delta IC divided by delta IB, delta IC by delta IB, we have put out, see, put out in this case VC equal to constant. लक्षात घ्या IB दोन्ही IB आणि IC आपल्याला चेंज करायचं तर थर्ड थिंग तुमची VC आहे. म्हणजे जर आपल्याला दोन ऍट ए टाइम तुम्ही तिन्ही थिंग कधीही काढू शकत नाही, लक्षात घ्या. त्यातली एक कुठली तर थिंग कॉन्स्टंट ठेवावी लागते. आता इथे जर तुम्हाला याच्यातलं चेंज इन बोथ मीन्स आउटपुट करंट टू द इनपुट करंट करायचं असेल तर त्यासाठी एक अदर थिंग ऍज अ कॉन्स्टंट ठेवावी लागते. सो इट इज नथिंग बट it is the ratio of the delta output divided by input. So output is nothing but a delta IC divided by input, that is a delta IB. So the ratio for HEP is nothing but a delta IC by delta IB. We are taking VC as a constant value. Okay, so when we have to be taking the VC taking as a constant on this line, म्हणजे जे इथले जे क्यू पॉइंट असते ना, त्या क्यू पॉइंट लाईन जे असते ना त्याच्यावर एक परपेंडिक्युलर क्यू पॉइंटला एक परपेंडिक्युलर लाईन काढायची. लक्षात घ्या, क्यू पॉइंटला एक परपेंडिक्युलर लाईन काढायची. ती लाईन परपेंडिक्युलर लाईनचे पॉइंट म्हणजेच तुमचे HEP चे पॉइंट असतात. लक्षात घ्या, म्हणजेच तुमचे डेल्टा IC बाय डेल्टा IB चे पॉइंट असतात. डेल्टा IC म्हणजे काय येणार, इट इज द IC2 मायनस IC1 डिवायडेड बाय अदर पॉइंट. अदर पॉइंट इंडिकेट दॅट दिस पॉइंट जे IC2 च्या रिलेटेड पॉइंट चा हा IB2 चा झाला, IC1 च्या रिलेटेड पॉइंट IB1 चा झाला. म्हणजेच your whatever the value of HEP is nothing but it is the ratio of the IC2 minus IC1 divided by IB2 minus IB1. We have taken the VC as a constant term. लक्षात आलंय का?
Yes.
5 मिनिटं आहेत. खरं तर सिलेबस मी डाउनलोड करेन. हे झालं तर तुम्हाला चॅप्टर होऊन जाईल. 1 मिनिट टेस्टच्या रिलेटेड पण बोलायचं आहे, पण बोलू आपण. हे नंतर घ्यायचं का आताच घ्यायचं? जास्त वेळ काय करायला नको. ओके, नेक्स्ट लेक्चरला हा पार्ट त्याच्या पुढचा चॅप्टरचा चौथा आहे तो घेऊ आपण. ते घेत असताना आपण काय करायचं की टेस्टच्या रिलेटेड 1 मिनिट च्या रिलेटेड स्लाइड मी नेक्स्ट याला घेणार आहे. अटेंडन्स द्या मला. आतापर्यंत जे झालेलं आहे किंवा एक लक्षात घ्या, ज्यावेळेस मी शिकवत असेल त्यावेळेस काय प्रॉब्लेम आला तर त्यावेळेस विचारायचंय. जर तुम्हाला अदर स्टोनच्या रिस्पेक्ट विचारायचं नसेल तर मला सेपरेटली तुम्ही कॉल करा किंवा व्हॉट्सअप करू शकताय. ओके, काय प्रॉब्लेम आला तर नॉर्मली हे तर कन्फर्म आहे की यावेळेस तुमची एक्झाम ऑनलाईनच आहे. ओके, अटेंडन्स द्या. रोल नंबर 1
Present.
2 3
Present, sir.
4
Present, sir.
5
Present, sir.
6 7, 8,
Present.
9, 10,
Present, sir.
11, 12,
Yes, sir.
13, 14,
Present, sir. Present, sir.
13 प्रेझेंट का?
Yes, sir.
ओके. 15, 17,
16 present, sir.
ओके. 18, 19, 20,
Present, sir.
21,
Yes, sir.
22,
Yes, sir.
23,
Yes, sir.
24, 25,
Present, sir.
26,
Yes, sir.
27, 28,
Yes, sir.
29,
Yes, sir.
30,
Yes, sir.
31, 32, 33,
Present, sir.
34, 35,
Present, sir.
36, 37, 38.
Yes, sir.
ओके. ऑप्शन नंबर सांगतो. 2, 5, 6, 7, 9, 11, 15, 17, 18, 19, 21, 24, 27, 31, 32, 34, 36, 37.
Sir,
Oh.
6 present.
6 प्रेझेंट. ओके. आणखी
20 present, sir.
20 प्रेझेंटच आहे. 18 प्रेझेंट. ओके. स्टॉप करू.
2 present, sir.
2 प्रेझेंट. ओके.
Sir, क्वेश्चन एकाच पेजवर लिहायचा का?
कोणते असाइनमेंटचे?
ISC मध्ये.
हा, एकाखाली एक पेजेस, एकाखाली एक लिहित राहायचं. म्हणजे समजा क्वेश्चन 1 असेल, क्वेश्चन 1 आला की क्वेश्चन नंबर 1 त्यातला 1 आकडा टाकायचा, त्याच्या पुढे त्याचे क्वेश्चन आन्सर, डायरेक्ट आन्सर लिहायचं. क्वेश्चन
क्वेश्चन
2
लिहायचा का नाही?
क्वेश्चन नाही लिहायची गरज, क्वेश्चन लिहायची गरज नाही. ओके.
आणि सर प्रत्येक पेजेसवर
म्हणजे नाही, प्रत्येक पेजेस वेगवेगळं, म्हणजे क्वेश्चन 1 असेल ते समजा तुमचा अर्ध्या पेजेस मध्ये झाला, अर्ध्या पेजेस मध्ये पुढचा असं लिहायची. नॉर्मल लिहिलं तर चांगलं होईल. नवीन क्वेश्चन नवीन पेजवर लिहिला तर चांगलं होईल. पण जरी नाही लिहिला तरी काय, सलग असल्यामुळं PDF सलग असल्यामुळं काय प्रॉब्लेम येणार नाही.
सर, सॅम्पल क्वेश्चन असेल तर सेंड करा की.
क्वेश्चन पेपर चालेल, ग्रुपवर सेंड करता येणार नाहीये. ते काय करायचं सांगतो तुम्हाला. क्वेश्चन पेपरचे आन्सर लिहित असताना समजा क्वेश्चन नंबर 1 आहे, त्यामध्ये 2 क्वेश्चन विचारायचे, क्वेश्चन 1 आणि 2. त्याचे आन्सर तिथे लिहायचं. क्वेश्चन नंबर 1 त्यातला पहिला आकडा, त्याचा आन्सर डायरेक्ट आन्सर लिहायचा. क्वेश्चन नंबर 2 त्याचा दुसरा आकडा, डायरेक्ट आन्सर. त्यानंतर क्वेश्चन नंबर 2 असेल, समजा लहान असतील तर त्याच्या पुढे लिहायचं क्वेश्चन नंबर 2 त्यातला पहिला किंवा दुसरा जे आकडा असेल तो टाकायचा. ओके.
सर,
हा,
किती क्वेश्चन असतील टोटल?
काय विचारलं?
टोटल क्वेश्चन किती असणार आहे?
नॉर्मली 5 to 6 असतील, म्हणजे 5 to 6 असतील. 30 मार्कासाठी असणार आहे टेस्ट. नॉर्मली त्याच्यामध्ये ब्लँक राईट इन अ ब्लँक पेज मध्ये असे 6 मार्काला असतील. राहिलेले 24 मार्काचे थिअरी क्वेश्चन असतील. लक्षात घ्या, 8 मार्काचे 3 क्वेश्चन आणि हे 6 क्वेश्चन असतील नॉर्मली.
MCQ असतात म्हणलं का सर?
हा, MCQ म्हणजे फिल इन द ब्लँक्स टाइप MCQ. ते 6 मार्काला असतील ते.
हा, ठीक आहे.
ओके, स्टॉप करूया.